Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. Today, we will be going over the area of trapezoids, And just as was the case with parallelograms and with triangles, the formula for getting the area of a trapezoid is unique. It is different than what it was for a parallelogram and different from what it was for a triangle. Now, you may see some similarities, but always make sure that you are using the right formula for the right shape. So if you were to look at the formula for the area of a trapezoid from a reference sheet, you would see something like this. Area is equal to 1/2 parentheses, base 1 plus base 2, close parentheses, times height. So 1/2 times base 1 plus base 2 times the height. And you'll find that has some similarities with the area of a triangle. And similar to the area of a triangle, you should know that whenever you're multiplying by 1/2, it's actually the same thing as dividing by 2, which is why I like to use this version of the formula. It's the exact same thing, and you do need to know that they are the exact same thing. Really, all we're doing is that we're adding base 1 and base 2. We're adding the two bases. And then we're multiplying by the height and then dividing by 2. So again, you're adding base 1 plus base 2, and then you're multiplying by the height, and then you're dividing by 2. That is the formula for how you get the area of a trapezoid, which begs the question, what is a trapezoid? So let's review that real quick. What is a trapezoid? So you have a trapezoid here on the side, and you will find that a trapezoid is a quadrilateral. That means it's a four-sided shape. And unlike parallelograms, so if I have a parallelogram like, let's say we have a rectangle, or maybe even a parallelogram like this. So whenever you're given a parallelogram, as the name implies, parallel, you see that opposite sides will be parallel. So in a parallelogram like a rectangle, we can see that this side is parallel to this side. And this side right here is parallel to this side. Opposite sides will be parallel. Similarly, with this one up here, with this parallelogram, we can see that this side is parallel to this side. And this side right here, the slanted side, is parallel with this side. Not only that, but we can see that opposite sides have the same measurement. For example, if this were to measure 4, this has to measure 4. If this measures 5, this has to measure 5. Same thing up here. If this measures 7, this has to measure 7. And if this measures 4, this has to measure 4. That's what makes a parallelogram, that opposite sides are parallel. Now, with a trapezoid, while it is also four-sided, it will only have one set of parallel lines, meaning that only two of the lines will be parallel to each other. And here we can see that this line up here, let me use a different color. We can see that this line up here is parallel to this line here on the bottom. If you were to look at the other two sides, if I were to stretch those out, this side and this side, notice that they are not parallel to each other because they do intersect up here. So again, in a trapezoid, you will only have one pair of parallel sides, one set of parallel sides, which means that you can also have trapezoids that look something like this. You might have these two sides as parallel. In this case, it's almost like the trapezoid is off on its side. As you can see that this side and this side are parallel. This would also be considered a trapezoid because, again, it's a four-sided shape with one set of parallel lines. The parallel lines on a trapezoid, ladies and gentlemen, will be the bases. And as we can see down here written, the bases in a trapezoid, the bases are going to be our base 1 and base 2. So these are our bases. The bases will always be parallel to each other. So a trapezoid will always have two bases. They will not be the same length, but they will be parallel to each other. And they will be perpendicular to the height, So just as with a parallelogram, the height will be the shortest distance between the bases. So it doesn't matter if I measure it here or if I measure it here. The shortest distance in this shape will be 4 centimeters. How do I know that it's the shortest distance? Because of this symbol right here. Because it is showing me that that imaginary line that is created when I'm measuring the distance between the bases, that it is perpendicular to the bases. Okay, so we can see that this would make a 90-degree angle. So look for that. So again, the bases are the sides that are parallel to each other. So in this case, we have 5 and 10. And the height will be the shortest distance between them, which is 4. And how do I know that it's the shortest distance? Because it is perpendicular to the bases. All right, so let's go ahead and fill in our formula. Similar to before, ladies and gentlemen, we want to make sure that we are rewriting the formula for every problem. So for example, this is actually number 1. So I rewrote the formula, area equals 2 base 1 plus base 2 in parentheses times the height divided by 2. So let's go ahead and fill in the values. So area is going to be base 1 plus base 2. And what is base 1? Is it going to be 5 or 10? Ladies and gentlemen, it doesn't matter, because we're going to add them together. It doesn't matter if you add 5 plus 10 or 10 plus 5. As long as you know what the bases are, it doesn't matter which you put first. So I'm going to put 10 plus 5. Yes, you could also have 5 plus 10. 10 plus 5. And we're going to multiply that times the height. And again, the height is 4. So times 4. And then at the end of it all, we're going to divide by 2. So again, we add the bases, 10 plus 5, we multiply by 4, and then we divide by 2. Ladies and gentlemen, as long as you are adding the bases first, it doesn't matter if you multiply by the height and then divide by 2, or divide by 2 and then multiply by the height, you're going to get the same answer. So 10 plus 5 is 15. 15 times 4 divided by 2. And we know that 15 times 4 is equal to 60. So the area is going to be whatever 60 divided by 2 is. And we know that 60 divided by 2 is 30. So my final answer would be 30 centimeters squared, or square centimeters. So again, ladies and gentlemen, we add the bases first. Base 1 plus base 2, so that's 5 plus 10, which is 15. Then we multiply by the height. 15 times 4 is 60, and then divide by 2, that gives us 30. Notice what happens if I divide by 2 first. So 10 plus 5 is 15. 15 divided by 2 would give me 7.5. And 7.5 times 4 actually also gives me 30. So again, as long as you are adding the bases first, you should get the same answer. All right. So for our purposes, I first added 10 plus 5 multiplied by 4, which gave me 60, and then divided by 2, which gave me 30. And that's pretty much it, ladies and gentlemen. That's how you find the area of a trapezoid. Let's do a couple more problems just to have this fresh in our minds. So again, we technically already did number 1. So let's go ahead and do number 2. Let's go ahead and do number 2 together. So here we're given this trapezoid. Notice that the bases, ladies and gentlemen, are going to be these 9 and 16, and the height is going to be 6, which happens to also be the side of the trapezoid. Why? Because it is perpendicular. So the distance right here, ladies and gentlemen, is a distance of 6 inches. All right, so let's go ahead and write down our formula. Let us go ahead and write down our formula. So the area of the trapezoid will always be base 1 plus base 2, so this is a plus sign, times the height divided by 2. So let's fill it in. So here our bases are 9 and 16, so 16 plus 9 times the height, which the height is 6, and then divided by 2. All right, so let's work this out. So I'm going to add 16 plus 9, which is 25. 25 times 6 divided by 2. Notice that I'm only going one step at a time. So I'm going to multiply 25 times 6. 25 times 6 is 150. 150 divided by 2. So I know that 150 divided by 2, and if you need to work that off on the side, you can. That's going to give me 75, and then it's going to be inches squared. And on Schoology, you don't have to put the units as long as you just put in the numbers. So my answer would be 75. Now, what I appreciate about this worksheet is that once again, the answers are on the bottom. And notice that if you don't find your answer, you did something wrong. But fortunately, we do find 75 inches squared over here. So yes, I do. That is my answer, ladies and gentlemen. All right, quite simple. For example, number 3, again, we add the bases, 20 plus 50 times the height times 40, and then divide that by 2. Pretty simple. We are going to be multiplying by decimals also. And also be careful. Be careful and with numbers like number 6. Notice that in number 6, ladies and gentlemen, again, we have to add the bases. Base 1 plus base 2, right? And the bases will always be parallel to each other. So in this case, the bases happen to be 1.5 and 2.5. And the height in this example would actually be 2.8. It's almost like the trapezoid is off on its side. On number 7, 8, 9, also be careful because they don't give you a shape, but they give you the basis and the height, which is really all of what you need. You just apply that to the formula. Add the basis, multiply by the height, divide by 2. Ladies and gentlemen, I hope that you found this video helpful. And with that in mind, I will see you next time.